Now that we've been back over absolute value equations, we're going to take a look at their graphs as well. But before we do that, we're going to take a look at the shapes of different types of graphs. So the first one that you should be familiar with from pre-algebra and algebra 1 is a linear graph. And linear graphs are just single straight lines. They can be vertical, they can be horizontal, or they can run diagonally from top to bottom or bottom to top. Absolute value graphs are always going to be V-shaped. Now they could be more narrow or they could be much flatter, but they're always going to have that distinctive V shape to them. This brings us to the formula for absolute value. We're going to look at what we call vertex or general form. And the reason why we call it vertex form is because we can find the vertex from the formula. So that formula is y equals a times the absolute value of x minus h plus k. Now, in this formula, A is the stretch, compress, or reflect. So think about a rubber band. If I stretch a rubber band, it's going to get narrower. So if A is greater than 1, it's going to stretch. If A is less than 1, it's going to be a compression, so it's going to flatten out down towards the x-axis. Then, independent of those two things, if A is negative, then it's a reflection. So what that means is it's going to reflect over the x-axis. If it's opening up, then if you make the A value negative, it's going to open down. It is possible to have both a reflection and a stretch or compress, but you can't have a stretch and compress at the same time. Now moving on, h is the x value of the vertex. But notice that in the formula, the h value starts off as negative. That means that to get the x coordinate of the vertex, we have to use the opposite of what h is. So if h was negative 3 in this example, then the x coordinate of the vertex is going to be 3. The final thing that we're going to look at in this formula is k. And k is the value of the y value of the vertex. And in this case, it's going to be the same. The coordinate is going to be the same sign as the k value. Now, because it can be a little bit difficult to understand without seeing these things, we're going to go over what the a value does. So if a equals 1, then you can see that the lines coming out of the vertex have slopes of both 1 and negative 1. This is what we call the parent function. Y equals the absolute value of x. Now, if a is greater than 1, the graph is going to be stretched or thinner, as you can see in the illustration. If a is less than 1, we're going to compress it, we're going to push it down towards that x-axis. And then if a is negative, you can see the reflection where the graph falls below the x-axis on this one. Now that we've seen what all the variables mean in the equation, we're going to go ahead and apply them to a problem. So the first problem that we've got is, what is the graph of the absolute value function y equals the absolute value of x minus 4? Now the very first thing that we look at is the a value. Since there's no a value present, we're going to assume that it's 1. So that means no stretch, no compress, and no reflect. The next step is to see what is the h value. And you can see in this example that the x value is alone inside of the absolute value lines. So that means that we're going to assume that h is 0. So the x coordinate for our vertex is 0. Then we look at the k value, and the k value is negative 4, so this means that the y value, or the y coordinate of the vertex, is negative 4. So we know that the vertex is going to be 0, negative 4, and we go ahead and graph that on our coordinate plane. Now that the vertex has been established, we need to choose two x values on either side of the vertex. In this case, the easiest values are going to be negative 2, negative 1, 1, and 2. Now, my suggestion to you would be, whatever values you choose on one side, go the same distance away from the vertex on the other side. So negative 1 is 1 unit away from y equals 0. Or I'm sorry, x equals 0. Negative 2 is 2 units away from x equals 0. So then you would also want to choose 2 on the other side. We're going to substitute each of these values into the equation for x and find the resulting y value. Now, as you can see on here, we've done this, and when we plug in negative 2 for x, our return is negative 2 for y. When we plug in negative 1 for x, then we get negative 3 for y. When we plug in 1 for x, then we get negative 3 for y. And when we plug in 2, we get negative 2 for y. Now notice that there's symmetry to this. We have negative 2, negative 3, negative 3, negative 2. And the reason for this is because if you do what I recommended just a little bit earlier, and you choose points that are an equal distance away from the vertex, then you're going to get this kind of symmetry. The next step is to create the XY chart. So you just take the x values that you plugged in, that you substituted, and then you get the resulting y value. So there's your XY chart. Once you've got that, you go ahead and put those on the graph. And you can see those coming up, and then you connect those points with 2 lines, and that is going to be your graph. In problem number 2, we're going to combine translations or movement of the graph. So the question is, which of the following is the graph of y equals the absolute value of x plus 2 plus 3? So in this case, again, there is no a value, which means we're going to assume that it's 1. And you can see that all of the graphs that we have presented to us all have the same slopes, so that really doesn't make any difference on this one. Now what we're looking for is the h value. And you can see that the h value on this one is positive 2. That means we have to do the opposite for our x coordinate of the vertex, so that's going to be negative 2. Then the k value is 3. So we know that the y coordinate of the vertex is going to be 3. So the vertex itself is negative 2, 3. That means we're moving the vertex 2 units backwards along the x-axis and 3 units up. Well, on the first one, we do have a movement backwards of 2 units, but then we also have movement down, so that's not it. On the second one, we move 2 units right, so that can't be it. On the third one, we move 2 units right, so that can't be it either. Then on the fourth one, we have 2 units back, and then 3 units up, so that is going to be our solution. In this third problem, we're going to start to see what happens when we change the value of a. So what is the graph of the absolute value function y equals 1/2 absolute value of x? Again, take a look at the a value, and this time it's 1/2. And 1/2 tells us that we're going to see a flattening of our graph. Next, we determine the h value, but in this case it's 0, so there's no horizontal movement. We determine the k value, again it's 0, so no vertical movement, which means that we've got a vertex at 0, 0. So the vertex has been established at 0, 0, or the origin, so now we choose 2 values on either side of the vertex. In this case, because we're going to be multiplying whatever is coming out of that absolute value by 1/2, the easiest thing is to use even numbers, that way we get easy integers to work with. So I'm going to choose negative 4, negative 2, 2, and 4. And we're going to substitute each of these values into the equation for x and find the resulting y value. When we do this, you can see that as we run through this, we're plugging in the negative 4, negative 2, 2, and 4, and we're going to come out with y equals 2, y equals 1, y equals 1, and y equals 2. Again, we've got that symmetry because we chose the correct points. Now you can do this without choosing symmetrical points, but it's going to be a little bit more difficult at times, and it's just a little bit easier just to do it this way. So then we have our XY chart, and you can see that the XY chart, all we've done is taken all of those values that we just found and put them into that, and then we're going to graph those points and then connect those points with a line, and there's our graph of the of y equals 1/2 times the absolute value of x. In this next problem, we're going to identify the transformation based off of the equation. So without graphing, what are the vertex in the axis of symmetry of y equals 3 times the absolute value of x minus 2 plus 4? Then we're going to explain how it's transformed from the parent function. So again, go ahead and write down your original equation, and then we're looking for the axis of symmetry. The axis of symmetry is always going to be the x-coordinate of the vertex. So it's always going to be x equals the negative h, or x equals h. So when we look at what is the h value, we're given x minus 2 inside of the absolute values. Switch that negative 2 to 2. That means that x equals 2 is our axis of symmetry, and it's also the x-coordinate of the vertex. Now we go back up into the original equation and we look at the k value, which is 4, and that means that k, the y-coordinate, is going to be 4 as well. So we get a vertex of 2, 4. What this means is that the graph is stretched by a factor of 3 based on the a value, and it moves to the right 2 units and moves up 4 units. In this last problem, we're going to take a look at writing an absolute value function from a graph. So we're asked, what is the equation of the absolute value function? Now, the first thing that you would want to do is identify where's the vertex at, because we're going to use that vertex point to find the a value. And you can see that the vertex point is at negative 1, 4. Now, the next thing that I would recommend doing is figuring out the graph's slope by the counting method. And to do that, what I'm going to do is I want to look for where does the graph go through the intersection of grid lines. And you can see that that is about 3 units away. So I've got my arrow running back 3 units and then down 1 unit, which means that my run is 3 and my rise is negative 1. So remember that slope is rise over run, so we get a slope of negative 1/3. Negative 1/3 then is our a value. We can confirm that it's negative because which direction does our graph open? It opens downwards. So now that we've got the negative 1/3, now we need to find what are the h and k values. We've already established that the vertex is at negative 1, 4, so we're going to plug those values into the equation, the vertex form of an absolute value equation. So we get x minus negative 1. X minus a negative, or x minus negative 1, is going to be x plus 1, and then we slide 4 in for our k value. So our final answer is going to be y equals negative 1/3 times the absolute value of x plus 1 plus 4.